I hope the videos so far have been helpful. If you have any suggestions on how they can be made better, or if you have any questions, please comment below. Let's get back to the grind and solve another problem. Best time to buy and sell stock. You're given an array prices where prices of I is the price for a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So we basically need to do one trade where we buy the stock on a certain day and sell it on a different day so that we have maximum profit, and it needs to be a single trade. The first way I can think of is to assume that we bought the stock on a certain day and then compute the best day to sell. In this manner, we can find the maximum profit possible when buying on each day and then taking the best possible trade. Let's look at this example with the prices for different days being 7, 1, 5, 3, 6, and 4. Let's say we buy the stock on day 1 for 7. On the following days, the prices are as follows. So when on the second day the price is 1, you can't sell it because it's a lower value and you're not making any profit. Then we have 5, we have 3, 6, and 4. So if you bought the stock on day 1 at 7, there is no other day where you can make a profit. In this case, the maximum profit being 0, or basically not doing any trade. In the second situation where you buy the stock on day 2 for 1, you can sell it for 5 and make a profit of 4, or sell it for 3 and make a profit of 2, 5, 3. These are the different profits you can make when you buy it for 1 on day 2. The maximum here being 5. Similarly, we can repeat this process by buying the stock on day 3 for 5, and you can't sell it here. You can sell it for a profit of 1, and you can't sell it here. We can repeat this for all the days in the list, and in the end we arrive at the maximum profit that can be made for purchase on each day. We take the maximum of all of this, we arrive at the best possible trade, which is a profit of 5. While this solution would work, we're basically using a nested loop, and the time complexity would be big O of n squared. And there should be a better way to do it. Let's try to optimize the solution that we just thought of. If we keep track of a minimum value that we've encountered so far, and then iterate over the list such that we sell on a certain day, then we can know the maximum profit that can be made. And in this manner, the same result can be achieved in a single pass. Let's look at this example. Let's keep track of a minimum and the max profit that can be made. So initially we have the minimum value to be 7, and because we've not dealt with further days, the max profit will initially be 0. When we encounter day 2, we update the minimum to be 1, and the current value is also 1, which means the profit is still 0. When we come to day 3, the price is 5, and the minimum so far is 1. Minimum remains 1, and the max profit is 4. Similarly, we can go ahead and fill this list as follows. 3 minus 1, which is 2. This would be 5, 3. So according to this max profit list that we've populated, this means that irrespective of where we purchase the stock, this is the maximum profit that we can make by selling on a certain day. And if you see the maximum out of this, that is 5. So we're achieving the same result in a single pass, which means the time complexity is big O of n. And since we're not using any additional space, the space complexity would be big O of 1 or constant space. Let's initialize max profit to be 0 and current min to the first element of the list. We can then iterate over the prices for different days. Then update current min as we encounter each price. We then need to update our max profit. Which would be the max of the profit we've seen so far, and the difference between price and the minimum encountered so far. So as we finish this loop, we would have seen the maximum profit that can be made using a single trade. So we can just return max profit. I think this should work as expected with a time complexity of big O of n and a space complexity big O of 1. Let's go ahead and implement this on Leetcode. We can first handle the edge case where prices is empty. We can just return 0. Initialize our variables, max profit, current min. Iterate over the list. Update current min. Update our profit. Then we can just return the max profit. Let's run this code to see if it works. Looks like it's working as expected. Let's go ahead and submit the solution to see if it works for all possible inputs. Yes, that works. So in this problem, we were only supposed to make one trade and compute the maximum profit. But in other variations of this question, you can make more than one trade, which makes the problem a bit more tricky. We'll cover those in future videos. Thank you.